All right, guys, welcome back to another lesson. All right, we're going to talk about proving that two triangles are congruent. Okay, and this lesson is going to be broken up into technically two parts. The first part is just getting some of the basic concepts out of the way. The second part is proving, doing like a T-chart proof to show that these two triangles are congruent. Okay, let's get started. Corresponding parts. So previously we learned that for these two triangles to be the same, all their sides and angles had to be congruent. That makes sense, right? I mean, going back to, I think I've used this example before, looking at these two erasers, okay? If I want to say that these two erasers are the same, then it has to have lengths that are the same, and the angles for each of these erasers have to be the same for them to be identical, okay? But here's the deal. We don't need every single measurement to be the same. I mean, they should be the same. Let me clarify that. We don't need to know that ahead of time, okay? So what does that mean? Well, let's just, I don't know. Nope. That's matrix. Sorry. That's different. Ignore that. So what that means, if I want to make a triangle, I don't need to know, how do I want to word this? If I want to recreate this triangle, I don't need to know every dimension. All I need to know is a couple of them to mimic what this triangle is, okay? So for instance, let's say this is my triangle, and I want to make another triangle just like it. Do I need the angles to make this other triangle to know for sure it's a duplicate? No. I think the sides are sufficient enough to prove that this triangle down here is going to be the same. Okay? Now I knew I drew this poorly. Okay? But that's the concept where we don't need every measurement in one triangle to prove that this other triangle is the same. Wow, that's loud. I'm so sorry. Okay, so do we need all six? No. We just need a combination of three measurements that we can use to duplicate it. And these are the combinations. S stands for side, A stands for angle. Okay, so you're probably wondering, okay, that's great, but what's that list mean? Well, we're going to go through it. Side, side, side. Okay? If all the sides in this triangle are congruent to all the sides in this triangle, then I can say that those two triangles are identical. I don't need to know that the angles match up. Kind of like what I drew back here. That's enough information. So for instance, if I look at this triangle, and this is all I had were the side lengths. I had no idea what the angles were. Can you still make another triangle that's the same using just these side lengths? And the answer is yes, you can. Okay? So then this is just listing the side lengths, and then there's the congruent statement, which we talked about in the previous lesson. All right, next up, before we introduce the next one, let's talk about a small vocab word, included angle, okay? If you ever hear that word, it's the angle that's between two sides, okay? That's the included part. It's almost like it's a friend group, okay? You have a friend here and a friend there, and you're in the middle. You're included in this group. So for instance, look at this triangle. I have these two sides that are congruent to another two sides that are somewhere out there. The angle that's between them, we call that the included angle. You can name it with 3 points or just one depending on the situation, okay? So each one of these is just showing you what an included angle is. Now, we're going to use this included angle in a new congruency theorem here, and that'll be side angle side, okay? So that's going to come up here. So let's just practice naming an included angle, okay? So let's say these side lengths are listed for us, and I want to find the included angle that goes with those side lengths. Okay? So let's take a look here. YE and ES. So it looks like the included angle is going to be E, the guy in the middle. So angle E would go with that. ES and YS. So I'm thinking with these two side lengths, angle S is the included angle. And then YS and YE, I think angle Y would be the included angle for that one. Okay? And you can kind of see a pattern whatever letter is seen in both of the side lengths, that's your included angle. Okay? The other two angles, we call them non-included. That's all. Okay, so let's use that included angle for the next congruency idea that we have here, and that's side angle side. Okay? So if I knew this side length, and the angle between them, that's enough information for me to recreate another triangle that is identical to it. Okay? Now some of you might be thinking, is that right? Can that really be right? Well, think about this visually. This side right here, there's only one way to connect these two sides, right? There's only one particular side length. This has to be a fixed length because these two are fixed. And these two are fixed, so this must be another fixed side length. So BC and EF, just by measurement, has to be the same because the other two sides are fixed between this included, or around this included angle. So since EF is the same as BC, we could say that these angles have to be the same because it's intersecting the other two sides at the same angle. I know that seems kind of weird that I'm almost saying, trust me, it's going to work. I used to do a construction activity with this, and just by the constructions you can kind of see that it works. But anyway, so that's side angle side for you. Okay, so we could say that this triangle is the same as this guy by side angle side. Okay, there's your proof for it. All right, let's flip it. Before we go to the next one, which is going to be angle side angle, we have to know another vocab term. That's called included side. Okay, and we're just flipping it. If you take a look, this side is included because it's between two angles that are congruent. Okay, so it's literally just flipping the situation from the included angle one. Okay, so HI and GH would be other sides that are be called included. Okay, so let's go ahead and let's just name the included sides given the following angles. Just a little practice. So here's Y, here's E. So the side that's between those guys that's included would be YE. Let's look at this guy. Angle E and angle S. Okay, what's the included side for that guy? It is ES. It would be between them. SY, here's angle S. Here's angle Y. What's the included side? SY. And you could probably see the pattern here. You're literally taking each letter and putting them together to figure out what that side is. Okay. So let's go ahead and talk about the guy that goes with it, angle side angle. All right. So if I know an angle, a side, and an angle in one triangle, that's enough information for me to recreate an identical triangle. Okay. So if you see this, you could say that these two triangles are congruent by angle side angle. That's your proof. Okay. And you can see that the corresponding parts that go with it are listed here along with the congruency statement. Okay. Okay, next one. We could say angle side. Okay, that's another situation where I can recreate two identical triangles only on that information. Now, please be careful. Let me just go back to the previous slide real quick. Okay, sorry to flip it back and forth here. Angle, side, angle. Angle, side, angle. You see how the side's in the middle, just like it's written up here in the statement? Let's contrast it here. This one is an angle, angle, side, angle, angle, side. Please be careful. The side comes after the two angles, okay? So there's a difference there. The previous one had the side right in the middle of the two congruent angles. This one has it after the two congruent angles. Okay, that's the difference between the two. All right, here's the corresponding parts listed along with the congruency statement. Now, quick warning. There's no such thing as an SSA postulate. Okay, what's that mean? Well, if I had two sides and an angle, that is not enough information to create an identical triangle. And the reason why is because I can create two different triangles with that information. So it doesn't work. So SSA, no. Easy way to remember, what's that spelled backwards? I'm not going to say it in the video. I'm not going to swear in the video, okay? But it spells something bad backwards, right? So therefore, you can't use it. You don't swear in mathematics, okay? You just don't. I mean, you might be swearing at the math teacher or at the math class in general. I get that. But we don't literally type out curse words when it comes to math. So that's one cool way to remember it, okay? So you cannot prove that two triangles are the same with SSA. Now, here's a nice, cool little animation just to show you, okay? Boom and boom. So you can see this is a side-side angle, side-side angle. Do you see that I can create two different triangles with just this information? So this is not good to prove that these two triangles are the same, okay? Not congruent there. Now, there is one situation where you could use side-side angle. I know, don't you just love in mathematics where you say you can't use this, not going to work, and then all of a sudden, well, there's an exception to the rule. Same thing here. You could do side-side angle, but it only works for right triangles. But we don't call it side-side angle. We call it HL, hypotenuse leg, okay? If the hypotenuse of each right triangle is congruent and their leg, one of their legs are, notice they share this one, so both of these are the same leg. Then we could say that these triangles are the same. Okay, so HL, H stands for hypotenuse, L stands for leg. This only works for right triangles, okay? It doesn't work for anything else. So just be cautious with that. Don't just say that it works for every. It doesn't, okay? Man, a lot of stuff going on in this lesson, huh? So here's the formal hypotenuse leg. And as you can see with the picture, each leg is marked, the hypotenuse is marked here. Now, just as a quick refresher, if you're not sure what the hypotenuse is, it's diagonally across from the right angle. It's always the largest side of that triangle, okay? So if you just need a refresher as what those are. Alrighty. Now, another warning. Angle, angle, angle doesn't work. That's not enough to prove that these two triangles are the same. Why? Take a look at the picture. These angle measurements are the same, but are the side lengths the same? No. I can actually expand or shrink a triangle, okay, given the same measurements, the angle measurements. Okay, so AAA, not enough to work. Okay, so just be cautious with that one too. So let's just list everything together. Okay, we could prove that two triangles are identical if we know all their side lengths. That's one way. If we know two side lengths and the angle between them, two angles with the side between them, two angles and the side after it, and then by hypotenuse leg. Okay, if it's a right triangle, we could prove that they're congruent by this as well. You could prove that two right triangles are the same using these ones too, but this is special only for that one. These two don't work. Side-side angle, 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 angle. Not enough information to say that they're the same. Okay? What do you think? Not too bad, to be honest with you. The hardest part is just remembering the list. Okay? And the more practice you do with this, the easier it does become. Alrighty? So, name that postulate. Alright. This is where I encourage you to pause the video and see if you can name which one's which. I'm going to go ahead and start naming them right away. These two triangles are the same by side angle side, SAS. So that reasoning is used to prove that these guys are the same. I don't need to know what this final side length is if it is the same. I don't need to figure out these angle measurements. This is enough to say that they're the same. Okay, and this one would be an angle, side, angle, side, angle, ASA. Down here, well, we have a side and an angle, side, side, angle. Oh, can't use it, right? Remember, that does not spell a nice word the other way. So these two triangles are not congruent then, okay? It may look congruent, but they're not. And then over here we have angle, angle, side, angle, angle, side. So AAS is what could be used for that. Okay. Now some people ask, why not angle, side, angle? Isn't it this? Angle, side, then angle. No, it's not. Remember, ASA, that S right here, okay, is directly between two angles. Okay? That's the included side. Remember what included side means. That's why that's in the PowerPoint here. Okay? So you got to be careful with that. Is this side in between these two angles? No. It would have to be here for that to work. So just be cautious. Okay, name the postulate. Once again, I pause the video. All right. First one, not congruent. Why? Because all we have are angles here. Can we use angle, angle, angle? No, so not congruent. Over here, what do we got? Yep, side, side, side. That's absolutely correct. Good job for answering that. Okay, next, what's this guy? Looks like what? Side, side, angle. Side, side, angle. Can't use. Bad word. Can't say it. And the last one. Well, you might say side, side, angle, huh? But, see this right angle? That's a right triangle. So side, 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 or I'm sorry, side, side, angle works for right triangles. Remember what it's called? Hypotenuse leg. The hypotenuse, for each one of these, they're congruent, and each of them has a congruent leg. So these guys, these two triangles, are congruent by HL. Okay? For that guy. Alrighty? Okay. Final little concept, vertical angles and reflexive sides. Now, I want to be very clear. When you approach these problems, a lot of times they will not mark this stuff, all right? They assume you know this, and you can mark it yourself. So just a word of caution, a lot of people say, well, Mr. McCullough, I don't know that they're congruent. Yeah, you do. First one, vertical angles, okay? These two triangles have a set of vertical angles because these lines are intersecting. They won't mark them for you, so you have to mark them, okay? And then decide, are these the same triangle? So just be aware of that. And then down here, reflexive. Here's the thing. When you hear the word reflexive, I want you to immediately think of the word shared. Okay? That's what reflexive means, shared. Is there a side or angle that these triangles share? Okay? Now look at this picture here. You see how this triangle and this triangle share that side? Okay? That means that this side is the same for both triangles, right? They're identical. It's just like, use the erasers. Boom. Ow. Okay, wasn't smart. Try it again. There we go. The side that's right here, let's say it didn't exist and it only existed when they came together. Okay? This is reflexive. Okay? They share this side, therefore this side and this eraser is the same as this eraser. Okay? So they were congruent. So because of that, we can mark them congruent, and then we can see that these triangles are congruent by side angle side. Both. Okay? So once again, they are not going to be marked for you, usually. Make sure you mark them. So now, for our final set of practice, and I don't think the video is too long, but then again, I won't know until I pause it, so hopefully it's not too long. All right, it's time to name it. So let's look at the first one. Okay, this one is side angle side. How do I know that? Well, it has a reflexive side. You see how they share this side? So that's congruent. So you can write a congruent sign there. So therefore, side angle side, side angle side. It works. Okay, over here, this one's side angle side too. We have vertical angles here and here. Okay, so since that's the case, look at each triangle. Side angle side, side angle side. All right, down here, this looks like angle angle side. It's hard to tell because the way it's drawn, but there are vertical angles here and here, right? So therefore, angle, angle, side, angle, side. That's how they're congruent. Okay, last one. Both triangles share this side, right? So they're congruent here. But is that enough to say that they're the same? I don't think so. Side, side, angle, side, side, angle. Can't use it. Not allowed. All right? So therefore, this guy right here doesn't work. Okay? So I cannot say with confidence that these two triangles are the same. Okay? They could be. I just need some more information. All right, and I believe that's it. Let me just... Yeah, I think that's going to be it. So just one final thing. You could have triangles that overlap, and when they do, they could share an angle or a side, which is still reflexive. Remember, reflexive is something they share. So look at these two triangles. The red and blue one, they overlap here at the bottom, so there's a reflexive side, so they're both congruent there. And then these two triangles, the red and blue one again, they overlap at this angle. It sucks those little leaves are there. Come on, go away. They're not going to go away now. But right there is where they shared. As soon as I point, they came right back up. Okay? So you could have a reflexive side or a reflexive angle pop up if the triangles overlap. Okay? And that's it, guys. Part 2 would be actually constructing a T-chart proof of what this is. So today, all we're doing is just naming why they congruent. Alrighty? So, hope you're doing well. I hope this lesson, this video helps you. If you have any questions, just let me know. And until next time, guys, I will see you in the next lesson.